Okay, so continuing with rotations, sometimes you'll rotate either figures or in this case, just a point in a coordinate plane. So my directions here, I want to rotate point M about the origin. So what that means is the point 0, 0, that's the origin. That's the center of rotation. And then it says specifically 90 degrees. Again, what that implies, even though it wasn't given, it's implied that I'm going to rotate it counterclockwise. So I do something similar to the last example. I want to make a ray where, in this case, the center of rotation, the origin, that's the end point of the ray, through the point that I'm going to rotate. And then I need to make a 90-degree angle. So instead of using my protractor, here's what I can do. Okay, going back to 4.1, parallel and perpendicular lines. If I take a look at this ray, the slope of this ray, up to right 3. So the slope is 2/3. And then if I'm going to rotate 90 degrees counterclockwise, okay, the other or terminal ray of the angle should have the opposite reciprocal slope because I want them to be perpendicular. If they're 90 degrees, they're going to be perpendicular. So I'm going to use the slope of -3/2. That's the opposite reciprocal. So a perpendicular slope, -3/2. So here's the point that's going to be the vertex of the angle. I can go down 3, right 2, but then that would rotate in a clockwise direction. So instead of going down 3, right 2, I go up 3 and then left 2. That's also a slope of -3/2. And maybe make my point a little bit darker so you can see right here. That's the ray where this would make a 90-degree angle. This has a slope of 2/3. This has a slope of -3/2. Those are opposite reciprocals of each other. And then what I actually did was found the location of point M prime. So I could use my compass again if I wanted to. If you have a compass, you could use that. You could actually make your own compass pretty easy. I'm not going to go through that, but you can like YouTube it or whatnot. But that would be the location of point M prime. I could also use my ruler if I wanted to. I could use a piece of paper like I did on the last example as well, but this would be M prime. The coordinates of M were 3, 2. The coordinates of M prime, -2, 3. Okay. Let's say I changed that angle of rotation and made it 180 degrees. Okay. For 180 degrees, here's point M. I'm going to rotate it still about the origin, but now 180 degrees. Again, what that implies is counterclockwise. Always counterclockwise unless otherwise specified, which occasionally, but not very often, it would be specified. Okay. So if it's 180 degrees, then I just extend this segment. Besides just extending it, if you have graph paper, use that. That's going to be extremely helpful, but I'm going to extend it so I know for sure that I'm making a straight line besides using a ruler. The slope here was up to right 3. So I can go down to left 3 and kind of just figure it out exactly where the point, the rotated point would be. Instead of making it M prime, I'm going to make this M double prime. The coordinates there would be -3, -2. And then I could change this. It should be a little or possibly a lot easier in a coordinate plane if you're rotating in a multiple of 90 degrees. So something like 270 degrees. Again, that would be in the 4th quadrant, first of all, but I could use the slope of this. So I'm rotating this original point M, 270 degrees. This is 90, 180, 270. I would need another perpendicular segment. So I'm going to use the slope of -3/2, even though I didn't want to go down 3 right 2 earlier because that would have been 270 degrees. I'm going to do that now, and that's the point of, I'm going to call it M triple prime. And then the coordinates of M triple prime, +2 and -3.